Okay, so today we're going to look at multiplying and dividing rational expressions. And so hopefully if you're having trouble, this video will help you. And so it says to multiply rational expressions, what we're going to do is we're going to factor each numerator and denominator if possible. So not everything can be factored, but if we can factor it, we're going to. And then we're going to make sure we list our restrictions. And so we'll talk more about that. I talked about restrictions in my first video, but we're going to see more examples of that coming up. Then our step 2, we're going to cross out any factor in the numerator that also matches with a factor in the denominator. And so what that does is it basically simplifies your expression like as you're going through. And then just like with fractions, with only using numbers, we're just going to multiply those fractions straight across. So you're not cross multiplying, you're going straight across. And so I wanted to show you first an example with numbers, and then we can look at some where we're adding variables to it. So here I have a fraction and then times another fraction. So based off my steps, it says that we're going to factor each numerator and denominator if possible. So 3 is a prime number. It can't be factored, so I'm going to leave that the way it is. 4, however, is the same as 2 times 2. 7 is a prime number, so I'm going to leave it. And then 6 we know is 2 times 3. There are no restrictions for a numeric rational expression when we have only numbers because remember our restrictions are when the denominator equals 0, and our denominator here is never going to equal 0 because it already equals 4 and 6. So our restrictions are when our denominator equals 0, and so we'll touch more on that later. And so then my next step is going to be to cross out any factor in the numerator that matches with the denominator. So that's that could be in either fraction. So you'll notice that I have a 3 right here in the numerator, and then I also have a 3 here in the denominator. And so even though they're on opposite fractions, it's okay, you can still cross them out. Now, if there was a plus sign in between the 2 and the 3, I could not cross them out. And so you can only cross out if the factor, if it's being separated by multiplication. That's what makes it a factor. So the 3 and the 3 are gone, and I have no other common numbers in my numerator and my denominator. And so now I'm just going to multiply straight across. And so this 3, once I cross it out, it really becomes a 1. And so 1 times 7 is 7. And then 2 times 2 is 4, and then 4 times 2 is 8, so 7/8 is my fraction. Now, we didn't have to simplify before we multiplied. We could have just multiplied 3 times 7 and 4 times 6, and if I did that, I would have ended up with 21 over 24, which 21 and 24 are both divisible by 3, so it would simplify to that. It's just a way, when you're crossing out before you multiply, it's just a way to kind of simplify as you go, so you don't have to deal with such big numbers. All right, so let's look at an example where now we're adding variables into it. And so, yeah, I got real crazy real quick, right? And so here's my expression. So I have this fraction times this fraction, and so my first step is going to be to factor. And so in the first video that I did in 7.1, I showed a factoring method that will work for pretty much anything, but it does have a few more steps to it than are necessary. And so I thought in this video I'll show you some quick shortcuts. You can't always use these shortcuts, but if you can, they're helpful. And if you can't, then you can always go back and look at my other video to see how to factor out, those expressions that you can't do quickly. And so my rule of thumb first, whenever I'm factoring, is I'm always going to try to see if I can factor out a greatest common factor first, because that's really the easiest type of factoring there is. And so let's look at this first expression, 4x squared minus 4x. Well, I see that both of these terms have a 4 in common. They also both have at least one x. So what I'm going to do is I'm going to put the 4x out to the front. And it's the opposite of distributing. So instead of multiplying that, I'm dividing each term by the 4x that I pulled out. And so 4 divided by 4 is 1. And then I pulled out an x, so I still have an x left. So 1x goes in my parentheses. And then negative 4x divided by 4x would be negative 1. And that's actually a factor, so I don't have to go further with the numerator. So now I'm going to come down here to the denominator. And so again, I'm going to look and see if I can factor out a GCF. And it looks like there isn't one other than 1, and it wouldn't really help us to pull out a 1. So I'm going to move to try the next thing. The next thing is if there's a 1 in front of x squared, like in this case, we don't see it, but it's there. Then I can use easy factoring. So easy factoring, what you're doing is you're looking for two numbers. They're going to multiply to give you negative 3 or whatever your constant is. And they're going to add to give you what your coefficient for x. So in this case, they're going to add to give you a positive 2. So I always start with whatever they're multiplying to give you, because there's going to be a lot less numbers that are going to multiply to give you something than are going to add to give you something. So I would kind of pull out the negative 3. And I know 1 times 3 are the only pairs of numbers that can multiply to give me 3. It's a negative 3, so that means that one of my numbers has to be positive and one has to be negative. And the way that I'm going to be able to tell is I'm going to come over here to what they're adding to give me, which is this positive 2. And so if the two numbers are adding to give me a positive number, then my bigger number has to be positive. If my two numbers are adding to give me a negative, then my bigger number would have to be negative. And so I'm just going to double check them. Negative 1 plus 3, they do add to give me 2. And negative 1 times 3 do multiply to give me negative 3. So those are my two numbers that I'm going to use in my factors. And so I'm just going to make two parentheses. This is easy factoring. I'm going to put an x in each since that is my variable. And then a minus 1 in one and a plus 3 in the other. It doesn't matter if you had switched them. They're really the same thing. So you could have put x plus 3 first and then x minus 1. That would be fine as long as your signs are with the right numbers. So make sure that the negative is with the 1 and the positive is with the 3. All right, now I'm going to factor the top right, so the numerator in the second fraction. And again, I don't have a common factor other than 1, but I do have a 1 in front of x squared. So I can again use easy factoring. And so I'm going to do that right here. So I have x squared plus x minus 6. They're multiplying to give me negative 6. So 1 times 6 or 2 times 3. I just list all my pairs of factors. It's a negative 6, so my signs are different. One's positive, one's negative. And they're adding to give me a positive 1. So my bigger number has to be positive. So I'm going to make all my bigger numbers positive and my smaller numbers negative. And so the two that add to give me positive 1 are right here. And so my factors are x minus 2 times x plus 3. And then 4x is already factored. It's 4 times x. So I'm just going to leave that the way that it is. Now here's where I need to list my restrictions. So my restrictions are going to be everything that would make the denominator equal to 0. So I'm going to start here. If x was a positive 1, 1 minus 1 would give you 0, and I can't have 0 on the bottom of a fraction. So my restriction is that x cannot equal positive 1. Right here, negative 3 plus 3 is 0. So x also cannot equal negative 3. I go more into this in the first video. I don't want to waste too much time on it. So if you are struggling with this, then go back and watch my first video. And then here, careful, it's not negative 4, because remember this is timesing. So 4 times 0 would give you 0. And so my restrictions are that x cannot equal 1, negative 3, and 0. So those are my restrictions. Now I'm going to go through and cross out any factors that the numerator and denominator have in common in either fraction. So I can cross out my 4x and my 4x. I can cross out my x minus 1 and my x minus 1. And my x plus 3 and my x plus 3. And so all I'm left with is x minus 2 on the top. And since there's nothing left on the bottom, it's a 1 on the bottom. And x minus 2 divided by 1 is just x minus 2. And so that whole thing simplified, is x minus 2. Oh, I think I went too far. No. All right, so dividing rational expressions, it's pretty similar to multiplying. We're still going to start out with factoring each numerator and denominator if we can, and then we're going to list our restrictions. Then we're going to change divide to multiply and multiply by the reciprocal. So this is known as keep, change, flip. I'm sure you guys have heard that before. So we're going to keep the first fraction, change the division to multiplication, and flip the second fraction. And then this is where it's a little bit weird. So your restrictions, they go by what you start with. And so we want to list all of our restrictions in the beginning. But then as we go through, when we flip the fraction, we'll have a new denominator. And so we'll need to add on to those restrictions. Okay, so we're going to list our restrictions. And then once we flip it, we're going to add more restrictions. And then you're going to follow all of your multiplying steps from here. So I'm going to do a very basic example, and then I'll do one that is a little bit trickier. And so this basic example, I don't have anything to factor, but I am going to list my restrictions. So my restrictions are that v cannot equal 0. Z cannot equal 0. All right, and so those are my two restrictions. Now I'm going to divide, so I'm going to keep my first fraction. I'm going to change to multiply, and I'm going to flip my second fraction. Now, notice when I flip my second fraction, that now I have a W on the bottom. So I need to add one more restriction, and that's that W can also not equal 0. And so now I have all my restrictions listed. And I can't cross anything out. I don't have anything in common on the top and on the bottom. So I'm just going to multiply straight across. This is UZ over VW. All right, so we're going to do a couple more examples, and then we'll be done with this section. So first things first, I'm going to see if I can factor any of my numerators or denominators, and I can't. They're all already as factored as they get. So then I'm going to list my restrictions. And so my restrictions I know that if x is 2, then 2 minus 2 is 0, so x cannot equal 2. And x can also not equal 4. So those are my restrictions. Then I'm going to keep, change, flip. So x minus 1 over x minus 2 times, flip my fraction. So x minus 4 over x minus 3. Now I have another denominator that I need to write a restriction for. So x also cannot equal 3. There's something that I can cross out. So I'm just going to multiply straight across. Make sure that you're putting parentheses around your numerators and denominators. So x minus 1 times x minus 4 over x minus 2 times x minus 3. And you don't have to distribute these out. You can just leave them the way that they are. Okay, so let's do another one. And so I'm going to factor the top, and lucky for me, I can do easy factoring. So x squared minus 9x minus 10. I'm looking for two numbers that multiply to give me negative 10. So there's 1 and 10, 2 and 5. It's a negative, so one has to be positive and one has to be negative. So I look at the middle. They're adding to give me a negative 9, so my bigger number has to be negative. And the two that add to give me negative 9 are these two. So the top factors to x plus 1 times x minus 10. I'm going to do the same thing. I already factored that earlier, but we'll factor it again. So x squared plus x minus 6. So negative 6. We have 1 times 6, 2 times 3. They're adding to give me a positive 1. So my bigger number has to be positive, and it looks like it's going to be these two. So the bottom factors to x minus 2 times x plus 3 divided by. Now these are a little bit weird. And so notice that I'm missing like my middle. I have x squared and I have my constant, but I don't have my like just x. So I'm going to write it a little bit different. I'm actually going to write x squared minus 1 like this. X squared plus 0x minus 1. And then I can follow all the same rules. So they're still going to multiply to give me that and add to give me that. So the only thing that multiplies to give me negative 1 is 1 times 1. And 1 would be negative and 1 would be positive. And look at that, they add to give me 0. So it's these two. And then the same thing with x squared minus 4. So I'm going to write that as x squared plus 0x minus 4. And so negative 4, oops, we have 1 and 4, 2 and 2. It's a negative 4, so 1 is positive and 1 is negative. And they're adding to give me 0, so it has to be these two. Okay, and so now that I have everything factored, I'm going to list my restrictions. So my restrictions are that x cannot equal positive 2, negative 3, negative 2, and then positive 2 again. So if I already listed it once, I don't have to list it another time. Now I'm going to keep change flip. So x plus 1 times x minus 10 over x minus 2 times x plus 3 times x plus 2 times x minus 2 over x minus 1 times x plus 1. And now I have a new denominator that I have to include restrictions for. So x also cannot equal 1 or negative 1. So these are all my restrictions. There's a lot of them. Okay, now I'm going to cross out any common factors in the numerator that is also in a denominator. So x plus 1 and x plus 1 are gone. X minus 2 and x minus 2 are gone. And that looks like it. Now I'm going to multiply straight across. So my final answer, simplified, is x minus 10 times x plus 2 over x plus 3 times x minus 1. And we are done.